Well, good morning and good afternoon, everybody. Welcome in from across the continent and beyond for another very exciting Exploring by the Seat of Your Pants broadcast. If you're joining us for the first time, and quite a few of you are today, we are all about bringing conservation, adventure, and science into classrooms around the world. And everything we do goes to our YouTube channel, so you can check out this program, its partner programs, hint, hint, nudge, nudge, lots to explore and discover right there. Now, before I dive in with Kristen and blow your mind with our epic topic today, I want to note we do have a Kahoot quiz. So between our talk and our Q&A, if you want to play along with a little 4-question quiz to test your understanding for some bragging rights, you can pull up that game pin in a separate tab. I will announce that several times and share it in the chat in just a second. Now, I'm really excited we are back in with our Canadian Space Agency series because for the last few years, our grand champions have been Parks Canada. When we bring them on, they get the biggest possible audiences, but they have been dethroned this year by the epic Canadian Space Agency. We have featured stories with astronauts, engineers, asteroid hunters, and more. There's so much to discover, again, all on our YouTube channel. So I really hope you do check it out. But we wanted to wrap up the month of March in style with Kristen. She's going to talk to us today about robots in space, training astronauts how to use robots in space, and some of the most amazing missions to the moon and beyond that we are working on in Canada and around the globe. So without further ado, I'm going to zip it. I'm not here to talk to you about robots in space. Welcome to the broadcast, Kristen, and thank you so much for joining us today.
Thank you for having me, Jesse. I'm excited to be here.
We have, as you know, almost 700 kids today from around the world, so no pressure at all, but I'm excited to hear from you. If you want to dive in and take us away, you are good to go.
None whatsoever. No, I'm excited to be here. I'm very thrilled to be talking about robots in space. It's a huge passion of mine and what I have focused my entire career around. So let's just jump right in and get started. A lot of what I'll be talking about today is going to be focused on the International Space Station. And if I was giving this presentation in person, I'd ask people, have you heard of the International Space Station? Which I'm going to shorten to ISS for the rest of this, this talk. So the ISS is this massive, massive orbiting laboratory above the Earth. It's about 400 kilometers above the Earth. It orbits the Earth 16 times a day, so about every 90 minutes. It's going at a speed of 28,000 kilometers per hour. It is moving fast, and it's close, but not too close. And we'll talk a little bit about the steps that we're going to take to move even further beyond the ISS as I get through this presentation today. If you want to think about the footprint as well, it's about the length of one football field, if you're a football fan, or 5 hockey rinks side by side. So it's pretty big, and the livable space there is about the equivalent of a 5-bedroom house. So when you hear about astronauts living on board the ISS, they've got quite a bit of space to move around and do their science and do their exercise and all of the other activities they participate in. The ISS is built thanks to 5 partner agencies. So it truly is an international collaboration, and the Canadian Space Agency is a part of that. We work with NASA, with the Japanese Space Agency, the European Space Agency, the Russian Space Agency, and it really is a collaborative effort and something that we've all worked together on so that we can have this truly magnificent orbiting laboratory that we can all learn from in orbit. But it didn't just end up that way. It had to start somewhere. And part of why I was invited here today was to talk a bit about my career. And I like to look back to where the ISS started and to liken my career to that in the same way, because we all have to start somewhere. And there are a lot of building blocks that need to come together for us to take those steps. So the ISS was formed kind of like a giant Lego project, or you might even have the ISS Lego at home, but it was put together piece by piece and block by block to become what it is today. So each module was launched individually, and then they were pieced together either robotically by Canadarm2, which I'll talk about, or by astronauts on spacewalks, the way that you see in this photo here. And the first module was launched back in 1998, and we've just slowly been building it and improving it and fixing it and modifying it over that entire duration of time. There are still things that we move up on orbit today, or modules that we add onto the ISS so that we can keep expanding and keep growing and keep learning. So I put up a little bit of a roadmap here, just to give an idea of where I started when I started my career and how I got to where I am today. I won't go through all of the steps, but high level, I studied aerospace engineering in university at the University of Toronto. There was something always interesting to me about space and something that I was always passionate about, but I didn't necessarily know that a career existed in the aerospace field. So I went into this program called Engineering Science, and it was a generic introductory program at the beginning with the option to major as I advanced through my degree. I realized I was really, really interested in robots. I got to build a robot in my second year of university, and that was kind of what solidified it for me. I was like, okay, I want to build robots, but do I want to build them for medical purposes or for space purposes? And I ended up realizing that space robots was really the thing that interested me the most, and I kind of set myself on that path. Now, that being said, all of these steps that you see here were not things that I had really well planned. So I was really interesting to see that, this was all about exploring by the seat of your pants, because I often think that I kind of took a career journey that was very much by the seat of my pants, where I kept my mind open and I looked for different opportunities, and I ensured that I was prepared at every step of the way. But I wouldn't say I sat down and said, okay, in 10 years, I want to be able to do this. And I just want to explain that to you guys, because, it is important to think about what you want to do and what you're interested in, but it's not absolutely crucial that you have that entire roadmap laid out well in advance. And that's absolutely not something that I did. I knew what would drive me and what I wanted to pursue. And then I just kept my eyes open and I kept those opportunities available to me, and I made those connections, and then I took those steps along the way as they became available. So some of the key points that I wanted to point out, back in 2014, so over 10 years ago now, I started training astronauts. And now I have, just over 10 years later, become the supervisor of that team. So now my job is to lead the training team for both the space station and the future Gateway robotic systems. And we're in charge of training the astronauts and training the flight controllers and certifying them to operate the robotic systems that we have on orbit. So I did want to go over a few of the notable moments from my career as well, because I've had the chance to do some really, really cool things, and I'm so grateful and so fortunate for these opportunities. But part of my career was actually training down at NASA's Johnson Space Center to get my flight controller certification. So that meant that I actually got to fly robots in space on the ISS as part of my job. I was sending commands to space. I was working among all the other flight controllers for space station operations. And I got to train down at NASA as part of that as well. One of the missions that I worked on was the robotics refueling mission, which was focused on showing that we could service satellites that were already on orbit. So using the robotic systems that we had, could we prove that we could interface with these satellites to do something that they were never designed to do? And, this was all towards the goal of sustainability and not having to launch new satellites, but being able to reuse what was already on orbit. On the top left, that's just an example of the workstation that I would command from. So a lot of data, a lot of screens, a lot of camera videos to see what we were doing in space, how the system was responding, what commands we needed to send to those systems, and being able to also watch a simulated version of that in real time, which is also where we would design and plan our procedures from. I was also part of the team that worked on David Saint-Jacques' spacewalk when he was on the ISS. So I helped write those procedures and do some of the training in the neutral buoyancy laboratory. It's this giant, giant swimming pool with a mock-up version of the ISS in there where the astronauts can actually train to do these spacewalks. So I got to be a part of the team that worked on that as well. And then I was on console supporting the spacewalk when he was up there. And then in the bottom right, you'll see an example of the workstation that we use to train our astronauts. So I'm there with Josh Kutrick, and we're going through some of our robotics training. And that's the team that I'm now back and working as a part of today. So let's talk a little bit about these robots, since the focus of today is robots in space. So I will go over the robotic systems that we have on the ISS right now, the first one being Canadarm2. Now, I talked about how the ISS was built up piece by piece. That would not have been possible without Canadarm2. We were able to robotically install all of those modules, and it was actually a coordinated effort between the original Canadarm, which we had on the space shuttles during the space shuttle program, and Canadarm2, which lives on the ISS. So we would take these modules out of the space shuttle and then hand them off between the two robotic arms and then piece them together on orbit to make the ISS what it is today. We still use this arm on a very regular basis. We've now gotten to the point where I'd say 90 to 95% of the operations are controlled from the ground by robotics flight controllers, which is the group that I was in previously. And we capture visiting vehicles, so things like the SpaceX Dragon or the Northrop Grumman Cygnus vehicle. They will come up with new science experiments or new supplies or resupplies for the astronauts, like their food, for example. And we use Canadarm2 to capture those vehicles and install them to the space station. Today, there's been an evolution where more and more of those vehicles are now autonomously making their way to the ISS. But a lot of what we were supporting previously was installing them robotically. We still do move these modules around. So if there's new science payloads that need to be installed, then Canadarm2 will work with another robot that we have, Dexter, to either remove a science payload or install a new one. And I'll show you what that looks like when they're working together. And in terms of how much we can actually move around, if you picture 8 school buses and how big and how heavy that would be, that's about the equivalent of what Canadarm2 can move around on the ISS. In terms of what we train the astronauts to use Canadarm2 for, so those free flyer or visiting vehicles that I spoke about, that is primarily supported by the astronauts on orbit. So we train them how to capture those vehicles, and then we take over and do the installation. And anytime there's a spacewalk where there's an astronaut on the end of the arm, that's also being commanded by an astronaut on the ISS. And how do they do that? Using this system right here. So this is the robotics workstation. There are 2 identical workstations on the ISS. This one is in the cupola. And as you can see, there are windows across the top as well that allow them to look outside to get that additional situational awareness to understand where the arm is and what it's doing. So if they're performing one of those captures, they can control it from here, and they can look out and make sure that the arm is responding in the way that they would expect, the vehicle is approaching in the way that they would expect, and then perform that operation from here. They have a setup that has 3 video screens that allow them to route cameras from either the robotic systems or other cameras on the ISS. They have hand controllers that they use to operate the arm. They have their central computer where they can monitor all of the different status messages from the arm itself. And then they have the panel just off to the left there. And I guess I can pull my arrow. There we go. So this panel over here has all of their safety critical commanding. So if they ever need to stop the arm or put the brakes on or anything like that, they can use those commands on the left-hand side there. So a lot of my job is actually focused on training them how to use this to then operate Canadarm2. So they come here and we go through an incremental series of lessons that teach them all of the different building blocks that they need to then do these types of operations. All right, Dexter. So Dexter was my favorite robot to work with. Not that I want to play favorites with the different robotic systems, but Dexter has a special place in my heart because of the role that Dexter played on the robotics refueling mission. But Dexter was an evolution to what we had done already robotically. And it's kind of like a humanoid-ish type robot in the sense that it has 2 arms with 7 joints and it can move them around in different ways, but it also has a body joint that allows it to rotate. So it can pick something up with one arm, rotate around and put it down, pick something up with the other arm and move that around as well. So we've done things like changing out old batteries and replacing the batteries on the ISS, taking off or installing science experiments, as I mentioned earlier, or doing things like proof of concepts, like the fact that we can now show that we can service a satellite on orbit. The neat thing about that was actually, that was the first time that we were doing dual arm operations. So both of Dexter's arms were operating simultaneously with 2 different types of tools to show that we could do that. The neat thing about Dexter, so one thing that I forgot to mention about Canadarm2 is that it has the ability to walk off. So each end of it has an end effector, and that's similar to what you'll see on the bottom of Dexter here, and it's able to move to different work sites across the ISS. But Dexter can't do that. So what we do is we rely on Canadarm2 to pick up Dexter and move it around with Canadarm2 as well. So we are able to then take the 17 meters of Canadarm2 and add the extra 3.5 meters of Dexter to have over 20 meters of a robotic system that then allows us to access all of the different work sites and perform all of the different tasks that we might need to perform on the ISS. So Dexter launched back in 2008, so it got up there a little bit later than everything else. And initially, we weren't really sure how much we would use it. We knew what a crucial part Canadarm played, but the goal was really to start offloading tasks from the astronauts so that they wouldn't need to conduct as many spacewalks. Going on a spacewalk is super cool. There's a lot of preparation and training involved, and it definitely is one of the most incredible things that we support, but it's also very risky to send somebody out there in a spacesuit. Space is hard, and all that preparation and all of that training, it does take quite a bit of time away from all the other things that they can do. So we thought, how can we offload some of that workload? And we showed that we could do a lot of this robotically. So little by little, we've been improving and increasing those capabilities. And now we can do tons of stuff using the combination of these two robotic systems to help reduce the workload that the astronauts have in terms of the spacewalks that they support. We do have one final robot up there, less of a robot than the other ones, but still a very important element, and it's the mobile base. And you can think of this like a space choo-choo train. When you think back to that first picture that I showed of the ISS and that whole length, that's about the length of those 5 hockey rinks or 1 football field, it's tough to get from one end to the other, and that's what the mobile base is for. So the mobile base is this portion that I'm circling here, and that can actually translate along the entire length of that truss of the space station. There are 8 different work sites that it can stop at, and the other very important part of this are these pins here on the 4 corners. Those are called grapple fixtures, and they can serve as an operating base for either of the 2 robotic systems, which means we can have Canadarm2 on there, we can have Dexter on there, we can have Canadarm2 holding Dexter on there, and then they can all go along for this ride to get from one end of the space station all the way to the other, so they can get to all of the different places they might need to go for all the different tasks that we support. One of the main benefits that comes from doing all of this stuff robotically and the contribution that Canada has made to the space station is that it allows us to then conduct science in space. And part of my career path included being an operations engineer and later the supervisor of that team. But that contribution allows us the time and the resources to then conduct these science experiments in space. Canada has done more than 20 science experiments to date now, and we're looking at different things. How does being in space affect your bones and your muscles and your cardiovascular system, your mental health, the way you process the space around you? So we're looking at all of these different effects and how we can countermeasure those. So what can we do to offset the really, really difficult and harsh environment of space on an astronaut's body to help them be healthier, either while they're in space or once they return to Earth? And the way that this benefits us here on Earth is that if you look at our population, we are increasingly old and increasingly sedentary. And a lot of what the astronauts experience on orbit is very similar to what we're going to experience as we get older and we're not quite as mobile. So it's very, very important that we take the lessons that we're learning in space and help to apply them on the ground, but also help to apply them to future missions. So I'll talk a little bit about some of that now. So some of you might have heard about the Artemis program or Gateway. And in terms of what Canada is contributing to that, so up next on Artemis 2, Jeremy Hansen will be a part of that mission. So he'll be launching with his 3 colleagues from NASA on this mission around the moon, and we're very, very excited to see him be a part of that. And then a few missions later, we expect, the modules for Gateway to start launching, and as part of that, Canadarm3. So Canadarm3 will be our even, further reaching next generation robotic arm, taking everything that we've learned on our previous robotics programs and applying it to all of these, future opportunities, looking at ways that we can improve autonomy, looking at ways that we can perform more of this exploration further away. We're increasing how long it takes to communicate and the way that we're commanding these things. And we're looking at these growth opportunities to, take what we've learned on ISS and see how we can apply it even further. One of the future contributions is also going to be a Canadian lunar rover. So that will come in the future as well. But it's really neat to be a part of the CSA and all of these next steps and future opportunities for exploration as we take that next jump from low Earth orbit to something around the moon. And the Gateway is, that next step. So if you think of the ISS and the way it's orbiting the Earth today, Gateway will be a very similar concept in that it's another space station, but it will be orbiting around the moon. It won't be inhabited by astronauts all the time in the way that the ISS is today. So that's another new model and new way of operating that we're looking forward to as well. The big part of my new job as supervisor of the robotics team here is developing the training program that will certify all future operators of Canadarm3. So any flight controllers, any astronauts, any support staff, anybody that will be supporting Canadarm3 operations will go through our training program. And that's a big part of what I work on a daily basis these days. So what's next? We've proven over the last 2+ decades that we can do science, we can do exploration, we can do all this stuff on the ISS in low Earth orbit with it, which is 400 kilometers above the Earth. And the next step that we're going to take is going towards the moon. So we're going even further. We're adding an extra 384,000 kilometers to that. The 2.5 seconds there is how long it takes to communicate once you take that next step further. And then anything that we learn there is hopefully going to help us benefit future missions to Mars and beyond. And now we're talking about millions of kilometers and a very, very long communication latency of between 6 and 44 minutes. So it will be a very big difference from what we're used to today, but we have to consider that astronauts will now be spending much more time in weightlessness. They'll have much more exposure to radiation. They'll be isolated amongst their crew members for a lot longer as well. We'll have these delays in communication, so we can't talk to them in real time the same way that we do today. And a lot of what they are going to be doing on orbit will be very much focused on what the crew's capabilities are. So all of these little steps, kind of like the building blocks for a career and the building blocks for the ISS, are really important to learn from so that we can then apply them to those future next steps and those future opportunities for exploration. So I've got a few bits of parting advice, I guess, or some thoughts that I have in terms of lessons that I wish I knew way back when I was trying to figure out what I wanted to do with my life. And the first is that it's okay to make mistakes. It's okay to change your mind. Nothing is set in stone. We're not expected to know everything at every given time. And I think it's really important to know that all of those things are okay. Those stumbling blocks are absolutely necessary when it comes to learning. Another big lesson that took me a while to learn was that it's important for you to find the opportunities that you want, but not just find them, but then ask for them. If you're telling people, hey, this is something I'm interested in, something that I want to do, that not only helps them find the resources that they need to then apply that to that project, but it shows that you're interested. It shows that it's something you want to do. And we're always looking for people that are interested and passionate about those things. It really helps with making sure you have the right person and the right fit for that job. Another important thing is to get comfortable with being uncomfortable. Big changes, big steps, all of those things are scary. I still find change scary, but I haven't been able to grow beyond what I know and what I've learned without taking those uncomfortable steps. And, it takes some time to adjust and get your footing at first, but in the end, it really is an opportunity for growth. So I encourage you to push yourself beyond those limits and, get out of that comfort zone. Maybe not all at once, take little steps here and there. But I think that was really important in helping me get to where I am today. And then lastly, you will probably hear this several times in your lives, but find something that inspires you, find something that motivates you. I wake up and I'm excited to do the work that I do. I love that I get to work in this field. I love that I get to look towards the future of space exploration and work with space robots on a daily basis as part of a team that is similarly inspired and motivated. So it's a whole group of people that are just really, really excited about space and really excited about robots. And it's a very fun environment to be a part of. With that, I will open it up to some questions.
Amazing. Well, we've got people pouring in saying they have a million questions in the chat, which is great. So if you have extra questions too, you can always send them to me. We'll try and get them to Kristen and get some answers after the fact, but we're going to take as many as we can in a nice long Q&A after some great advice and a super cool picture to wrap up that broadcast of the ISS and the moon. But before we do that, before we come for your questions, we are going to play our little Kahoot together. So 4 quick questions, and what you win is Kristen and I's everlasting respect. So no pressure at all. And Kristen, I don't know how your setup is, but if you want to come out of screen shares, you can see us again, make sure everything's good that way. Yeah. You're welcome to. But we're going to get underway with this in just a sec. And then Miss Stevens' class, you're going to be our first question when we get underway. So here we go. If you're new to Kahoot, the faster you answer, the more points you get. Let's do this thing and get underway with 40 plus of you. That's awesome. All right. And Kristen, if you want to help us with any hints, with any of these questions, you're welcome to chime in.
What if I don't know the answers?
I know. I think you might. We'll see. All right. 3, 2, 1. One of our key themes. Okay. Astronauts are too smart to need teachers. When you're an astronaut, you're just a super genius. You don't need anyone to help you with anything. You're the best. Is that true or false? What do we think? Kristen, what were you talking about, helping astronauts? I think that's a big part of your career. What do you think?
That's my whole job. I hope that they need us.
Well, with 5 seconds to go, there's your spoiler answers. If any of you picked, there you go. Way to go there. No one is too smart to need teachers. Everybody can learn something. And that's where amazing people like Kristen come in. So let's see what that does to our leaderboard. Fast Mouse has our lead. Fast Mouse was very fast. And Space Ibex, what are the chances of a name like that? Awesome. Okay, I kind of rooting for Space Ibex. All right. A lot of our work revolves around the ISS. Can you see the ISS from your house? Can you go outside and look and see the International Space Station? Yes or no, never. It's way too far away.
I think we might need a third option in here, Jesse.
I'm gonna bring up a website that maybe people can use to go look for the ISS. Woo, what a mix. Okay, I've seen the ISS. It is like, it's awesome. You can type, okay, so spotthestation.nasa.gov, type this in, say I'm in Corner Brook, Newfoundland, where I am, and it'll be like, oh, at like 9 p.m. at this angle, the ISS will go over. So there's always satellites going over. You can see satellites any night. You can literally see the spacecraft with people inside it. You can wave at people that are like flying through space, which is crazy. I love the world. It's great. All right, Fast Mouse takes your lead. Ooh, big shift in the leaderboard. It's very tight though. One more question. 2 more questions total. Canadarm 3 will be on Gateway, which is an outpost which will allow us to explore what? The sun, Mars, the moon, or Antarctica? Unexpected. The Antarctic people would be very surprised to hear that Gateway was checking them out. What do we think in this very wrong scale model of the solar system? I love that you talked about signal latency, which is a weird concept, but basically if you're in a car with your parents and they turn the wheel, the car turns automatically. If you turn the wheel of Opportunity rover on Mars, that signal takes like 20 minutes to get there before the thing turns, which is crazy because it's that far away. So the moon is our correct answer. A lot of you thought Mars, and I'm glad that you're so obsessed with Mars. Mars is worth being obsessed with. But alas, it is the moon. There you are. This question has no points. I just wanted to get your thoughts. And how inspiring Kristen has been. Who wants to work on robots in space? You do or no, not for you? What do we think? No right answer. I'm just curious. I want to work on robots in space. The idea that we can like control something on a spacecraft that people are living in to help understand new worlds and science that will benefit us for hundreds, if not thousands of years to come is very neat. And so, half and half. Interesting. Okay. You know what? I will say when I was in school at the age of these kids, maybe 1 in 20 kids wanted to work on robots. So the fact that we got 50% is very solid.
I didn't even know it was an option at that age. I wanted to be a pediatrician.
Which is a great job as well. Awesome Bear is third. Second place is Yellowhawk. And first for all the marbles before we head to Miss Stevens' class for our first in-depth question, she says, is Great Duck. Great Duck, kudos to you. If you are any of these folks, let us know who you are in the chat. Miss Stevens, if you want to flick on your mic and come on in, you are good to go. Let's do this thing and take your question.
Hi, yeah, so it's just the picture that you showed before showing that, showing the scale of the ISS versus the moon versus Mars. I don't think it was to scale because in reality, if let's say you have a globe, you find those globes.
I'm not hearing it.
I'm hearing it, Kristen.
I did not hear it.
Oh, so they start. Okay, Miss Stevens, if you're not being heard by her and it's a long question, could you share a little bit more of it in the chat? But one of the essences at the beginning was the idea that in your models showing the ISS and the moon and Mars, they weren't to scale, which is correct,
no,
right?
They were not to scale. No, I didn't have any indication of a question coming through. I'm sorry. I wasn't just sitting here silently. I couldn't hear anything.
No worries. Okay, so not to scale. Yes, Mars is much, much bigger than the moon. The moon is much, much bigger than the ISS. But please do share more in the chat. I'm sorry the audio wasn't coming through. We'll head to Madame Karine's class, joining us in Quebec. If you guys want to come in with a question, hopefully all is well.
Aiden? I need to
I can see them. There we go. Okay.
That's it. Stop. Okay, why?
Aren't there more robots on the ISS?
Why aren't there more robots?
Yeah,
Kristen, we need more robots. What's the deal?
We always need more robots. Yeah. I assume you mean why are there more on the ISS than there are on Gateway? The reason for that is the ISS is much bigger than Gateway is planned to be. I unfortunately don't have a picture of the two models side by side, but Gateway is significantly smaller since it's not going to be crewed as often as the ISS is. We've also increased the capability of the robotic systems that will be on Gateway, so they can do a lot more with a much smaller footprint based on what we've already learned on the ISS today.
And just in case the question was going here, why don't we just pack the whole thing with robots? Why do we only have the few that there are, not like 100 robots? Or can you say...
Well, there are a lot of resources that go into operating any system on any of these stations. So we have to consider that there are other things like all of the life-sustaining systems that require power and data, and those resources are all limited when we go into space. So we want to make sure that we're really using what is required to do as much as we possibly can with.
It's very hard to get things to space, and it's very, very expensitive. So we tend to send the best of the
best
that we've worked a very long time on before we get them up there. So I love this question, guys. We're going to head to Glenview and then Miss Parrish's class live. YouTubers, Miss Heshek's class, Miss McCool's class. Great questions. I'm coming to you guys in a sec as well. But Illinois, come on in and take us away, Grade 3. Hey.
A lot of going up where you can be seen. There you go. Nice.
What do you use to communicate with the people in space?
Ooh.
I'm also not hearing that question. I don't know what's happening on my end.
I got that one. So what do you use to communicate with the people in space? Is there any special tool? Is it the Signal app? Perhaps not. Is there anything that we want to share on how we're talking to them?
So we have voice loops that we use on the ground that allows us to communicate from our control center here in Canada to the one that we have in NASA. And there's also another one in Huntsville, Alabama, and the one in Houston. So we have the voice loops, and we actually have space to ground loops that allow us to talk directly to the astronauts. We also do have ways to set up private conferences with their family so that they're able to have video calls and telephone calls with their family members on a regular basis to keep that contact as well.
So really, really high-end, like phone, Zoomy type things, but with special software that you guys use as sort of the gist. It's not something that's like commercially available.
I wouldn't even say that they're super high-end because this technology has been up there for over 20 years. So, but yeah.
Oh, great question, guys. All right, Mrs. Parrish's class, and I'll be here in case we don't get any audio through, but hello, welcome into Petrolia.
Are you going to be sending anything to Europa to check out the...
Like the moon there? I love this question. Awesome. So, Kristen, are we going to send anything to Europa to check out the moon? We've talked about Europa a lot in our past broadcasts, so I'm really curious. Anything that you do that's going there or no?
You mean me personally? Like something that, no, maybe one day, that would be cool. No, we're very limited on launch mass and capability, so we're not sending too much extra stuff up there, unfortunately.
Yeah, but we are sending missions to Europa, and to this point, if you're keen on planets that we're sort of looking that we think might have life, Mars is top of the list, Titan, Europa, and Enceladus. So there's 4 places that are sort of our leading candidates in the solar system that we think could have something like a bacteria or something in the ocean, and they're super cool missions, and you should check out the Canadian Space Agency website and NASA for lots more. So cool question, guys. All right, we're going to do a whole other round with our live classes in a minute. I'm going to relay whenever the audio is being a little weird for Kristen's sake, but we've got some great ones from YouTube. So Miss Heshek's class, they're in Athabasca. They want to know, where are the zero gravity labs? Where are you testing this? You talked about the pool. What's the deal? Where can we go? And can we go to visit these places personally or no?
So this pool is down in Houston at NASA's Johnson Space Center. So it is land-based, and it's something that you could visit as part of the tours that they have set up there. That's where a lot of the training happens. They also have a virtual reality facility there, and that includes this mock-up that allows them to almost be suspended from the ceiling to then do some practice as well with the whole virtual reality environment around them. So yeah, they are all ground-based.
Super, super cool. We've done features on the neutral buoyancy lab, so the super pool many times before. It's one of the coolest things in space science, and I encourage you to all check it out. All right, Miss McCool's class, they're joining us in Etobicoke, which is where I am from, so nice to have an Etobicoke group. They want to know, how much different is Canadarm3 from the original one? Why not just put the original one up there? What's going on?
Well, the original one being Canadarm or Canadarm2, because we did start with Canadarm. That one was only 6 joints and had a fixed base inside of the space shuttles. There were 5, 1 per shuttle. Canadarm2 is 7 joints and able to walk off. But technology has advanced a lot since either of those two systems launched. So now we can do things with better electronics, with better materials, with better hardware, just overall. So we've just kind of taken those capabilities and improved them. It also is smaller in size, so we don't need the same large arm that we have with Canadarm2 on the gateway, because it is a smaller space station overall. So it's a smaller arm there. And we have increased capabilities. So there will be different tools and different things that it's able to perform based on different needs on the gateway versus what we've seen on the ISS up until now.
Very cool. And I want to note we've got a lot of Southern Ontario classes today, and you might be surprised to know that some of the best space robotics work in the world is done in Southern Ontario. Like some of the universities there, you talked about MDA, like some of the coolest innovations on planet Earth are like right in your backyard. It's where I grew up. So I hope you guys take the chance. If you're keen and you want to work on space robots, you are in exactly the right place if you're there. All right, we're going to do a rapid fire round. We've still got 10 minutes together, lots of time for Q&A. So Miss Stevens' class, if you guys want to share live, I'll relay it. So you can come and ask, and shorter is probably better. Or there we go. Let's see. Come on in. Talk to me.
Do you think the ninth planet, known as Planet X, is real?
Is that what they're calling Pluto now?
No, this is a different thing entirely. This is like
okay.
We're past Pluto. We've acknowledged that it is a dwarf planet. What about a secret dark planet that we have not yet discovered? Any thoughts?
Well, I personally still think Pluto's real, just because I grew up with Pluto being the ninth planet in my mind. So, the whole learning scheme for what planets are up there is still kind of ingrained in my mind, because that was what I grew up with for so long. That being said, there's just so much out there that we haven't been able to explore that we don't know yet. So I haven't discounted anything as real or not real until we're able to prove one way or the other.
I love that you highlighted it that way. And again, space is huge. It's ridiculous. You're looking for a dark rock that is like beyond the furthest planet. And even with the most cutting edge technology in the world, that is not something that's like, oh, we look here and we'll find it. So it's a big mystery. We don't think so just yet. Most astronomers we've talked to when we've had Planet X brought up are like, pretty iffy on it. But who knows what we'll find as we keep looking. So great question.
I see ninth planet and I automatically go to Pluto. I can't get that out of my brain.
It's time, Kristen. We can accept it. We can accept it together on this broadcast. Madame Karine, if you guys want to come on in, Quebec, take us away. Hey.
Tommy?
Let's see.
You say? Gabriel?
How come it's cold in space?
Ooh, how come it's cold in space?
Yep.
Cool question.
So there's no atmosphere in space. Once we go beyond the atmosphere, which is kind of what protects the Earth, that's why we have the temperatures and the weather systems that we have. But beyond that, it's just a lot of nothingness. There's no sound there. It's just freezing cold. And it's because you don't have that nice cozy bubble keeping you in there.
I love highlighting this, and this is a concept that's a little bit more advanced than most of our classes are learning in your everyday school. But basically, you are kept the temperature you are because lots of little particles are hitting you. And when you're down on ground level, there's lots of particles hitting you. If you go higher and higher, if you're at the level of a plane or like the top of Mount Everest, there's a lot fewer particles hitting you, which means you're colder. And if you go too far into space, there's no particles hitting you.
Nothing.
All your heat just leaks out and you die. So don't go to space without a spacecraft or suit. It's not a good idea. That's why it's cold in space. All right. Let's head back to Glenview. Come on in, guys. Miss Parrish will come to you after a few more YouTubers to be our last question of the day. But Illinois, hey guys.
So I keep hearing like people saying like Katy Perry's going to space. Everybody like that's famous, like rock stars and stuff are going to space. And I don't really sometimes believe that that's true. Because like, why would they go to space? It makes like kind of no sense.
Ooh, space tourism as a query.
Yeah.
Kristen, this is a big one, and I have some answers for this too, but it's a cool question.
I'd be curious to hear your answers as well. But yeah, so space tourism is becoming more and more popular, where you could basically buy a seat to go to space, which is a very temporary few minutes that you'll spend in space, and then you come right back down. So it's not truly going to space in the way that you think of, an astronaut training for several years to go and perform a long duration mission. It really is just a quick pop in, say hello, look down at the Earth, and then go back home.
That's basically it. And so there are a lot of people going to space. They absolutely are going to space. Like, they are passing the line of which we consider space. Blue Origin, so Amazon has been leading the charge in this. We've sent many space tourists to space at this point, and in fact, more and more are going in the next few years. But as you mentioned, and I really want to harp on this, if you go up to space and you're there for 2 minutes and you come down, it's one thing, as opposed to an astronaut, like Canada's 4 astronauts, like NASA's many astronauts that are training for years, that are usually people that are doctors and engineers and pilots who speak multiple languages and have spent, some cases decades working on incredible tools, working with people like Kristen to hone their craft and become trained professionals. So it's a little bit of a different thing, but it's super cool. Like, don't get me wrong, I think I'd be one of the first people to be like, yes, let's go to space and pop up there. But it's very, very expensive. It's outside of the realm for 99% of people on this planet. And I love that you're thinking about that question. That's a really neat query. All right, a couple more from YouTube, and then we'll wrap up with Mrs. Parrish's class. Miss Green's group, they're joining us in Richmond Hill. They want to know, what robots are you most excited to send to space in the next few years? No pressure.
Well, I mean, that's an easy one, because the one that's really very much on my radar right now is Canadarm3. So that's definitely the one that I'm most excited to see on orbit. A lot of what we're doing right now is still the early design and conceptualization and figuring out how we're going to do certain things and how we're going to train those things. So I'm very excited to be a part of, the early phases of all of that, and then eventually see that on orbit in a little while.
Super, super cool. Can't wait myself. It's going to be exciting. A lot of the missions that when we started doing Exploring by the Seat of Your Pants, the people were talking about, oh, this is going to happen in 5-10 years. They've already gone up now. James Webb Space Telescope's a great example. So come back to us in 2029 and we'll see where we're at with some of our ongoing missions. Very cool question, guys. All right, one more from YouTube, and then Miss Parrish, you're going to wrap us up. I love this one. Kristen, when did you know you could be a scientist in space? And you mentioned your educational background. What is one barrier we have in our world today as we understand challenges on Earth? So you can take this in a few directions, but like, when did you know you could do this? And what's a big challenge that you faced en route?
Okay, when did I know? I don't know that I've ever known. As I said, I kind of just took all of this in stride, and I looked for all these opportunities as they became available. But I remember it was when I first started as a contractor here at the Canadian Space Agency, and I learned about the team that was operating, all of this stuff from the ground. So they were the ones sending the commands to space. And I was part of the engineering support team at the time, which was also super cool. But then I found out, like, oh, I could be the one sending those commands. That is extra cool. And I remember talking to the supervisor at that time and saying, okay, I'm going to work for you one day. And it was around that time that I really knew that this was the path that I really wanted to focus on and really advance my career within. In terms of the barriers that I personally faced, it was just access to information at the time and knowing what was available to me, and not seeing a lot of people in this role, or seeing anyone in this role really. So, not knowing what was available was a huge hurdle to overcome. And it just wasn't the same in terms of being able to see these, these live streams, or see these posts on any of these social media platforms, or even the access that we have on all the different websites today. That just didn't exist when I was trying to chart my path. And I'm so grateful that programs like this exist, that opportunities to talk to people that are in these fields exists as well, because I think that really helps to show you what's out there and what you're capable of achieving.
Thank you so much. Geez, I love when people take their answers and thank us for exploring. It's so much fun to get to bring stories like yours to so many kids. As I said, over 700 kids, all the options of what they could have chosen in the month, what they could have chosen with their day, and they wanted to hear about you and robots in space. And it's exciting for us as well. So thank you. Mrs. Parrish, you're going to wrap us up with one final question before we bring in all our classes to say thank you and farewell. Kristen, Audrey, please, you stick around when we're done the broadcast as well. But Petrolia, wrap us up. Hey, guys.
Does the Canadian lunar rover have a name yet?
Ooh.
That might be a better question for Audrey, actually, who's hiding in the background. I don't believe that a name has been chosen yet. I know that there was a vote that was put out. There were 4 possibilities. 4. I don't think that we've announced a winner just yet. So unfortunately, I don't have an answer for you today.
Okay, I will check in on this and make sure we get an answer if we do have one, but we are in the final 4 anyway. So if the voting's still open, keep those votes coming in. And if not, hold tight and stay tuned, everybody. Kristen, it's been such a fun broadcast. Thank you so much for joining us, your passion, your expertise, all of it. And what we do to wrap up every show, I'm going to bring in our classes to say a big thank you and farewell. So Ms. Stevens' class, Madame Karin's class, Avoca West, Mrs. Parrish's class, thank you so much, everybody. Have a wonderful day. Farewell for now, guys. Thank you so much.